Variables are things you can change, but if you wanted to declare it where you can't change it, use the keyword let instead. And so now, if we try to set it, just do greeting equals hi, then that's fine. And it shows us in the sidebar that greeting's hi now. But if we try to change our constant greeting to hi, then it gives us an error. And so errors show up in the left sidebar. You can click on it and see what it says. And it says you cannot assign to a let value. So let, we declare a variable with let, and it's immutable. So that's it. That's kind of the basic. Now, let me get a feel. How many of you guys have done a Swift tutorial before? Okay, good. How many of you guys have actually run an app that you made using Swift?
So kind of, it was like hello world.
Yes.
Yeah. And yes.
Okay. Cool. So we have some pretty advanced people here. So I'm gonna go a little bit faster than I normally would because we've got advanced people. But anybody has a question, ask me, because I'm sure other people have it too, and I'll be happy to answer it. The next cool thing that we can talk about is optional values. And it's this new concept in Swift that if I declare something with a question mark, so in this case we'll just say our new string. So we see a new syntax here. The constant greeting, I was able to just set it to a string, and it inferred the type, so it knows I'm supposed to be a string. But in this one, we're telling it explicitly, okay, you're going to be a string that's optional. And so the question mark means that it can be a nil value, it means nothing there. So why is that important? Well, when we make a dictionary, which is kind of a lookup table, so you might imagine it's like a collection of boxes, and each box has a name and something in it. So we can do that with people's ages. Okay, so now we've got Jill, Bob, and Joe, our dictionary. And if we want to get one of them, then we can say so by doing that, we got Jill's age, but it says some in the sidebar here. So why does it say that? Because when you get values from a dictionary, they're optionals. And so to actually use it, we could use what's called forced unwrapping, put a bang after it. And now you see that it's just 46. So why do we want to do that? Because if we wanted to, for example, multiply Jill's age times 2, then we get an error if we try to just do it without unwrapping optional. So that's how you force unwrap an optional, with the exclamation point or the bang. Now, this is bad to do because we don't actually know if Jill's in the dictionary when we call it, and if we force unwrap something when our app is running, then the app can crash. So how do we protect against the app crashing? We can use if let syntax. So what it does is it checks if this value can actually be something, it's not nil, and then you can use the variable name that you declared up here inside of the statement. So if anybody's completely new to programming, this probably doesn't make sense, but you can ask me what it means. Okay, cool. All right, so last thing I'm going to show you, kind of beginner stuff, is for loops, because they're fun to play with in playgrounds. So this is a new concept in Swift called a range. So it's 1 all the way to 9. If we wanted to go 1 all the way to 10, then we just use 3 dots instead of the less than sign. So in the sidebar, we can see it runs 10 times. And if I put the less than sign back, then it'll say it runs 9 times. And so every time that we do our loop, then we are multiplying x, which is something 1 all the way up to 9, times itself. And if we go over here and we click on the circle with the plus in it, then that will bring up our assistant editor, and we can actually see the value of that over time, over each calculation, which is cool. So I can click on this point, and I can see at that time it was 64. So is anybody having trouble pulling that up?
Where did you get that?
So if you mouse over this 9 times, and then you click the little plus. Awesome.
I'm getting some red dot on a for loop. Maybe it did something wrong. If extraneous at 2 top level, fix it.
Move that down.
Oh, okay, right, that's what I did wrong. That extra squiggly thing is what I did. Yeah. Okay. It's done. Okay. Perfect.
So let's talk about functions now. That way we can start to get a little bit more powerful. So a method or function in Swift, you start with the func keyword. And in this case, we'll just say print hello. And when we do that, we're going to use print ln for print line. And we're going to say hi. And then in order to call our function, we just use the name of it with open and close parentheses. And now we can see that it prints it over here. And if you actually want to see the console, then you just open up the assistant editor, and we can see that the print line gave us hi. Cool. So now if we want to start to get into this cool stuff, we could say print area. And that's going to take a height, which is an int, and a width, which is also an int. Let me close this so we get back. Oh, and make sure your ints are capitalized. And then we're going to let the area equals height times the width. And then we're going to use print line and print the area. And then we're going to call our area function with 10 and 12. Okay, So we see that it prints out 120 for us. And we actually only need the print line. Cool. So here's something that either you guys who have done Swift before might not know. You can name these parameters. So for example, if I want to say width and before them, then in my function call, then I just use it like this, width and it still works. So you'll notice that in a lot of the frameworks that you use, they use named parameters just to make it, read a little bit more clear about what they're doing. And if you wanted to instead make sure that those parameters were just height and width, then all you have to do is use a pound sign. And then when you call the function, instead of calling 10, 12, you actually call it with height. And width in there. And we can always check our results in the sidebar, and it's still working, and we don't have any errors. Okay, but now let's do a different trick with. What if we want to call it? We can remove our pound signs. We want to get a default values. We've just used an equal sign up in the parameter area. And so now we can call print area with nothing in it, and we still get our 120. But if we wanted to specify something, then we can't, even though we don't have a name parameter, we can't use 5,6. So you'll see we get an error. And that's because when we have optional values, we can give it only one of them. So for example, I could do width 5. And so now it's going to use the height default value that we gave and instead use 5 instead of 12. And so see that we get 50. So the default value 10 times the 5 that we gave it. And we can override both of them. So it should be 30. And we see that in the sidebar. So you'll notice that by using Playground, you can quickly test and make sure your code's working right. Make sure you have no errors, and make sure that you're getting the right results by checking the sidebar. And then you can just copy it and paste it back into your iOS project.
How would you do that not null?
How would you do what?
Not null. So make sure you have a value.
So
So you're gonna put 0.
oh,
So not null.
okay. So 0 is just an int. It's not a null value. But yeah. But if we wanted to enforce that we can't have 0, so what would I do? I mean, I'd probably just use an if statement. Does anybody else have any ideas about that? No?
Are you talking about the optionals?
Well, he doesn't want to be able to call this with a 0 parameter.
But you
Like
have
for the
to
height of
write
width. Yeah.
So it's
Yeah.
why?
Is there any kind of input testing to validate the input values before you print anything? If you're passing external values
Mhm.
from whatever processor, isn't there some type checking you can do?
Yes. Well, so one of Swift's advantages is that always make sure that you're calling it with the right type of value. So it shouldn't be able to pass anything.
Okay.
It's not right. If you get into stuff, you could do something like this. You could say if let height as. So then it's saying that the height has to be an int value. Does that make sense?
But isn't that already enforcement?
Yes, it is already enforced up there. So it's already pretty safe. Okay.
Are there-
So, yeah, go ahead.
The question is, I'm just starting, so is there any tutorials that have like an IoT flavor to it? Like, well, here's a tutorial to talk to an LED, for example,
I haven't seen one of those.
something simple.
Yeah.
Okay.
I haven't seen those. That'd be a good one.
Because I integrate Salesforce API with an LED, so whatever, it's just a simple HTTP handler, whatever.
Mhm.
So you can kind of work with that kind of idea of passing HTTP requests and intercept that and do something like an LED or send a pop-up message to a hardware port.
Right. I'm with you. That'd be cool. I'll look and see if I can find one.
Okay. Because I try to get that information from Salesforce, and it's like a wall. It's terrible. You have to figure it out with yourself, dig it out on the internet.
Now we're going to write a couple of simple algorithms that will help us, actually implement something in an app. So this one's going to be called test of visibility. And you're going to learn a new thing here called the return. So notice that we have our name parameter by there, and then this arrow, which is a dash and a greater than sign, means we're going to return an int. And in this case, it's an optional int. So that means we could return a number, or it could be the nil value. Okay. Now what does this do? So this percent sign is called modulo, and when you use it in math and programming, it means that it's going to give you the remainder. So if we divide A and B, and the remainder is 0, then we're going to return a nil value. Otherwise, we're going to return the remainder of A modulo B. So let's test that out. If we call it with 10 and 2, then we get nil because they're evenly divisible. But if we use 3 instead, then we get an optional 1 back. So if we wanted to use this now, then we need to use our if-let syntax or force and wrap it with a bang.
Is there a difference between optionals here and like point CC?
I don't know. So does everybody understand what happened there? If you had any questions, so. And now we're going to do something even more real. We're going to make a search algorithm. So we'll search for a named parameter named who, which will be a string. And then we're going to return optional int again for as a position in the dictionary.
Is there a difference between string and NS string? I saw some suggestions.
You saw what?
It was giving suggestions to use.
Oh yeah. So in a string is like the old string from Objective C. Yeah. And string can do everything in a string. So we have our dictionary up here. Let me make sure it's still there. Yeah. So it's called dictionary. So we can actually use that in here. So for name, comma, age in our dictionary that we had. If the name of the person equals what we passed in for who, then we'll return their age. And then in Swift, as soon as you have a return, then it gets out of the whole function. And so at the end, we include this return nil because that means that we went through the whole dictionary looking for the person's name and we didn't find it. So now we need to say, no, we didn't find it. So since we have that nil value, we're going to use it in code the right way now. So we'll use the if let syntax. If let age equals search. So, and we see that this returns not found because the age value for the search is nil, and so it goes into the else part. I'm going to go over some views and stuff. Oh, you gotta go.
Yeah, thank you. I'll shoot you an email.
Okay, cool. So, yeah. Everybody clear on what happened?
Not really. Not really.
No worries. So when we call search, so this is the simplest part of it. We call search, and we're going to search for duck. And when we get up here, we're going to go through our dictionary that we had cleared up there, but we only have Jill and Bob and Joe, I think, in there. So duck's not going to be found. It's going to take each name and age, and then it's going to check and see if the name is equal to who we passed in. So we pass in duck, and then it'll return the age of whoever it if it found the person, it'll return it. Otherwise, it'll return nil for nothing. And since document dictionary, it returns nil, and then we can't, the if let fails because age is a nil value, and so then we go into the not found, and it prints it out here.
Okay, so the function search is going to return a nil.
Mm-hmm.
Well, it's still gonna go to the next
Yes,
line,
because
say, if let the age whatever.
age gets set to nil, so that means the if fails and it goes to else.
Okay, not found, okay.
Okay. Now I think what I want to do is, and we can come back, but I want to just kind of show some of the things that you can do in a playground. You take a lot of code, so it'll be hard for us to type. And we'll just kind of step through them. So what we have here is we're going to make a color, in this case cyan, and you can see that it gets displayed in the sidebar there. So that's cool. And then we're going to get a font, 42 size, and then we're going to make a string. And this is complex, but all it's saying is that we're going to have a string that has both a color and a font. And so if we click on the eyeball, then we can see that it's 42 size, and it's the cyan color that we made. And then we can make a frame and a view and a label inside of the frame. And if we add that to our view, then now we get our label inside the view. And so there's a lot of code, but if you actually didn't want to code a UI view, then you could do it in the playground and you could check and see your progress there. So images. You can actually put images, and the way that you do it is in Finder, you right click on your playground file and you do show package contents, and then you make a resources folder. And so let me just show you that really quickly so everybody can figure out how to do it. So in the design objects, that's the one that we're on. I'm going to right click show package contents. And then in here, there wasn't a resources folder, so I just made a new folder called resources. And then I put a bunch of images in there. And the reason why I did that is because now I can use them in the playground. So I can make a new image view, and I can set the content mode property of it. And then if I look, then there's my image. And I can even add it to the hello that I had from before. So that's pretty cool. We can start to really make some complex views. Now, let's say that we want to make a class for a minion, so we can create instances of it. If you've ever done, if you ever learned object-oriented programming, this is, what you would do. So our minion has some attributes, name, image, favorite activity, and then it's got an init method. And all objects have init methods. They come with one that's got no name parameters out of the box. So that looks like this. Just init. So this doesn't do anything. But we actually want to make one so that we can set the name favorite activity when we make a new minion. And so this is like a function, basically. It's just a function, and it has some parameters in it. And then when we call it, we want to make sure that we set self.name, so that refers to this one with the name that we passed in. And the favorite activity. And then we need to set the image, but UI image, it returns an optional. And why does it do that? Because when we pass in, when we use an image name in here, that name couldn't exist. It's like the dictionary. Maybe there's not a person named Doc. Maybe there's not an image named Doc. So it has to return optional, because if it doesn't exist, it's going to tell us it's nil. And so we can only set our image if it exists. Otherwise, we're just going to give it an empty UI image. And then finally, we'll set a description, because that way we can print out what our minion likes. So now let's go here. So minion Bob, and then we're calling the initializer method by the name of the class, and then open close parentheses. And then we're passing in the name and favorite activity. So that's name and favorite activity up here. And so now we've got minion Bob, and then we can call his description. And we get minion Bob likes orbiting in the air. So that's pretty cool. And we can actually see what minion Bob's image is by clicking on the eyeball there. So anything confusing about that? You guys are doing awesome. So if you've ever made a table in iOS, then you know that it's much more complicated than you would think it would be. Because you have to set up a data source, that your table is going to pull from. And the table has to do things like allocate the cells as they are needed, so that when you scroll, you're only using 10 cells and they're getting reused as you're scrolling. So that means that you have to make a lot of code. But in the end, we go down here, we can actually look at a table of our minions. And inside the playground. And so again, another cool way to like prototype what you're doing, and even prototype the cells inside of the table. So on this theme of doing awesome things in playgrounds, let's look at even more. When Apple released Swift, one of the things that they showed off was this balloons playground, and then they actually released it on the Swift blog so that we could check it out. And so they also do a cool thing where they have like kind of a book inside of the code, so you can read what's going on. And I'll link to this in the notes from this session. But notice that our assistant editor isn't open, so we need to do that. And when we do, then we get a sprite kit, which sprite kit is Apple's 2D games framework. And we can see that it's making new objects, shooting out of cannons, and when they collide with each other, then they disappear. So you can see that you can even make, a game in a playground and then test it out there in the sidebar. And when Apple also released a new framework for making 3D games, and so if you look at that, so we'll open up our assistant editor. And then when it runs, we can see that we've got 3D objects. So again, this is Scene Kit, and I'll also post the code for this too. And then finally, one thing that I just recently found, and it has some kind of complex topic that I want to go over, is hopefully my computer doesn't die from having all these open at once. This. So if you've ever applied for a developer job, you might have had to do a fizz buzz in your interview. And this is how you do fizz buzz in Swift. So the point is that you count from 1 all the way up to some big number, and if the number is divisible by 3, then we're going to write fizz. If it's divisible by 5, then we're going to write buzz. And if it's divisible by both of them, then we write fizz buzz. And so by using a switch statement with this tuple, when the remainder is 0, so it's the number that we passed in divided by 3, remainder is 0, the number that we passed in divided by 5 is 0, then we write fizz buzz. And then the underscore in this case means that we don't care about it. So you can use underscore anytime you don't care about something. Don't care about returning it or don't care about receiving it. So we only care that the first number is divided by 3 and we'll write fizz. And so let's look at what that looks like in the assistant editor. So we count from 1 all the way to 100, and we're going to print the line of what we get returned. So 3 is divisible by 3, we get fizz. 5 is divisible by 5, so we get buzz. And then 6 is fizz. So we count all the way up. So the main point is that this is like a pretty short solution for this problem, which might have taken you much more in other languages. And I kind of glossed over this earlier. So anytime that you put the backslash and parentheses and the variable name, then you can do anything you want inside of a string, and it'll just get the value out of it. So it's like executing whatever you put in there inside of the string. So that's much nicer than what Objective-C used to do, working with strings.
So it can be an expression, not just a
Yeah. So we can do math inside of there. Yeah. So another kind of advanced topic is enums. So imagine that we have, a train, and we want to know what's happening with the train. The train's either on time or it's delayed. When it's delayed, then it's delayed by a certain number of minutes. And so then we can represent that down here. The good news is that the status is on time, and the bad news is the status is delayed, and the minute it's delayed or 90. And so you'll see this a lot when, like another example is a compass point. The compass could be north, south, east, west. It could be the types of cards that are in deck, so like spades, hearts, those kind of things. So anytime you have something that's kind of representing states, then you can use enums. And you can do a cool thing like assign a variable inside of the enum. And so now let's look what happens when we make a train class and make it printable. So we can use a switch statement with enums so that when we check the status of our train, we can do different things depending on what's happening. So if it's on time, then we just return on time. If it's delayed, when the minutes are using a range from 0 to 5, and then we just put a slight delay, and if it's delayed any other amount, so there's an underscore, then we write delay.